Last section in chapter 5 is the half angle formulas. Half angle formulas are similar to the double angle formulas in that you're going to have identities. You have several new identities. What's important is keeping organized, watching your plus or minuses, making sure your algebra is working out. I want to go ahead and prove the first two. And the way I'm going to prove the first two is with the double angle formulas. So I know that looking at the first one, the cosine of 2 theta is equal to 1 minus 2 sine squared theta. And when I solve for this sine theta, I'm going to get that by adding 2 sine squared theta and subtracting, actually this is a minus sign here, minus cosine 2 theta. So I added 2 sine squared theta to both sides and subtracted cosine 2 theta from both sides. And then what I want to do is divide by 2. And I'm going to see that your sine theta is equal to plus or minus the square root of 1 minus cosine 2 theta divided by 2. This is the formula for this. However, there's one thing that's wrong, that's different, and that is this theta and this 2 theta. Before we made a substitution on one side that affects the substitution on the other side, and what I want to do is that same type of substitution. Instead of 2 theta here, I'm going to replace it with an A. So I'm going to say that 1 minus cosine A over 2 is equal to sine of, and now I have to figure out what theta equals. If 2 theta equals A, I can just show that down here. 2 theta equals A, then theta must equal A divided by 2. That's my A divided by 2 is equal to my theta. So this is the half angle formula that says that the sine of A over 2 equals 1 half square root 1 minus cosine A divided by 2. And we'll talk about that plus or minus in just a little bit. Same exact thing can be true for this other one. Instead of the one identity, we're going to actually choose the other identity that involves a cosine squared. Again, solving for that cosine theta, I'm going to add 1 to both sides. Divided by 2. And I'm going to get cosine theta equals plus or minus cosine 2 theta plus 1 divided by 2. And I'm just going to change this around just a little bit. I'm going to do the same substitution as I did over here. So my theta becomes A divided by 2. So I'm just going to say, I'm going to switch the sides too. So it's going to be cosine A over 2 equals plus or minus the square root. I'm just going to change this 1 by the commutative property. 1 plus cosine A divided by 2. I think maybe it's easier to see that if you substitute A over 2 in for theta, you put A over 2, your 2's are going to cancel, and you're just left with A. It's easier to see. So that identity is this one. So we proved both identities in this first one. And again, this plus or minus, I want to say that it's not like you've seen a plus or minus before. If you had x squared equals 9 and x is equal to plus or minus 3, what this plus or minus means is that both 3 and negative 3 satisfy the equation. You put them in, they work. So that means that really x can equal negative 3 and x can equal 3. you're going to choose either the positive or the negative. So in other words, Santa Claus is going to tell you if it's positive or negative, not both. It's a different meaning than what you've seen before. Those are two identities, half angle for sine, half angle for cosine. Then they're going to be two for the tangent. I can go ahead and prove the tangent one, although that's going to take probably another 5 or 10 minutes. So what I'm just going to do is give you the tangent ones. The tangents are not dealing with positive and negative, but there are two of them. Because there are two of them, you have to pick and choose which one makes sense. And when you have proofs, you have to make sure you're choosing the right one, or it's going to be impossible, or I should say more challenging to prove, pick the wrong one. So be careful, write them both down, make sure you have them both accessible. Again, for the test, they will be on a piece of paper that you can see. Think up front, think of the one that makes most sense to choose as you're going through your problems. Then what I want to do is go ahead and do a few problems involving the sine and cosine identities and show you why it's important to deal with that plus or minus. So, this is an explanation of the plus or minus situation. And so I'm going to do that when it's time in the problem. And I think that'll make more sense than to explain it before then. The question is, what is the cosecant of a over 2 if you know the sine of a is equal to negative 3 over 5 and it's in the third quadrant? This is a problem that you've seen before. There's nothing new other than the fact that it's a half angle instead of a double angle. So the process is exactly the same, except you have one more layer that you have to do, and that's the plus or minus. So what do you have to do? Well, third quadrant, you want to draw it to get the cosine. So I want to draw in the third quadrant, and you're going to see that the sine is going to be 3 over 5, which makes that a 4. Therefore, the cosine of a is a negative 4 over 5. We've done that a lot of times in here. You get really good. But if you put down a positive 4 over 5, everything you do is going to be off. And it follows that. That's how important that negative sign is. Be extremely important on that negative. Okay, so now you know that you have the cosine. The next thing I want to do is solve for the sine half angle, because I want to do the reciprocal of that for the cosecant of the half angle. The sine half angle, I want to start with the identity that says plus or minus 1 minus cosine a over 2 all under the radical sign. Then it's a matter of just substituting in. So it's going to be plus or minus square root 1 minus. The cosine here is a negative 4/5, which be very careful here. Negative 4/5. Right? The negative sign comes down. You're substituting in that number over 2 equals. These become plus 5 over 5 is your 1, so it's 9/5 over 2. Multiply by 1/2, the same thing as divided by 2. So to make a long story short, you're looking at square root of 9 over 10. And now we come up with this plus or minus business that we have to talk about. Which one do we choose? Now, the problem is that you're given that the A right here is in the third quadrant. That's A. However, when you're doing this, you're talking about A divided by 2 now. It's no longer A. It's A divided by 2. So you can't just go up and say it's in the third quadrant because it's not A. It's A divided by 2. So you have to adjust. You have to figure out what is the quadrant of A over 2. The way you figure out what the quadrant of A over 2 is in two methods. And that's what this is all about. The first method said, okay, if A is in quadrant 2 is between 180 and 270. That hopefully should make sense. If you're looking at quadrant 2, you're looking at, quadrant 3 is between 270 and 180. That's this angle. So A is between 180 and 270, but I don't want A, I want A divided by 2. So in an inequality, if you divide everything through, what happens? Your 180 becomes 90, your 270 becomes 135, and your A becomes A divided by 2. A over 2 is between 90 and 135, which means now you're in the second quadrant. 90 and 135 is right here. And that just moves. So your angle that was in the third quadrant moves to the second quadrant when you have the angle. Now, there's a shortcut of doing this. You can do this every single time you want to find out what the quadrant is for the half angle. But there's a shortcut that is this way, and if you want to use that, that's fine. To me, that makes it a lot easier, but you have to understand what's going on in it. What this is all about is it says that if you have A in quadrant 4, it's going to move to now quadrant 2. So these numbers represent the quadrants of your angle, your full angle. The new quadrants 1 and 2 refer to the half angle. So your angle in 4 means that your half angle goes to quadrant 2. Your angle in 3 now moves to the second quadrant. So your half angle is going to be in quadrant 2. And then if your angle is in quadrant 1 or 2, it's going to move to quadrant 1 for the half angle. So this is a shortcut in terms of knowing where the half angle moves to. And it's pretty easy to see. And then what you would do is you'd apply Santa Claus on top of that to figure out if they were positive or negative. Because this is where S is, this is where K is. As a result, you may be thinking that sine half angles will always be positive. Sine half angles will always be positive because they're positive here and they're positive here. Going back to the problem. We're in the third quadrant. Half angle for the third quadrant means this right here, if moved to that one, which means that your sine is going to be positive. So this is equal to square root of 9 over 10, positive, which means now the cosecant is going to be square root of 10 over 3, because square root of 9 is 3. You did the circle. All of this work, an explanation could be wrong if you can get that negative sign. Or if you didn't substitute this in right. Be very careful on this. Take a look at number 1. Number 12. Secant of b over 2 equals what? Sine b equals negative 1/3, and b is in the third quadrant. Well, you're going to do the same exact process, but again, leave a lot of room for these problems. Don't cram them in. Make nice drawings. Make sure you label things. don't do stuff in your head. First thing we're going to do is draw it. We're in the third quadrant. Sine B is going to be 1 over 3, which means it's 1 over 3. If I were to figure this out, that's going to be square root of 8. Using Pythagorean theorem. Means the cosine of B is equal to negative square root of 8 all divided by 3. To get the secant of B over 2, I want to get the cosine of B over 2. How do I do that? I write down the formula. I then substitute in. Let's go. 1 plus negative 8 square root of 8 over 3 divided by 2. I want to go ahead and clear out that 3. I multiply it through the top and the bottom by 3. So when I do that, I get 3 minus square root of 8 all over 6. You have radicals within radicals, which we haven't seen too much of before, and you can't really simplify those. That's the good news. One other thing that we have to do is choose my positive or negative. Again, you could use this diagram, a quick diagram, to figure out where it is. This is for 3. 3 again moves to quadrant 2. That means that your cosine is going to be negative. So it's a negative square root 3 minus radical 8 over 6. You want the reciprocal of that. So that means that you're talking about negative 6 over, oops, let me do that again, negative square root of 6 divided by 3 minus 2 square roots of 2. That's your answer. They're getting complicated. We're not going to worry about the radicals and the radicals. Keep in mind you have 2 tangent ones as well. I feel like I talked a lot today. So keep your identities in front of you. Be careful on the positive and negative. Be careful